Okay, so let's get started. We're going to be taking a look at working with our closed loop Lambda correction once again in this training module. We're going to be focusing on doing an actual demonstration live with our vehicle. That's going to be a Honda EP3 chassis with a Honda K24 engine swap. And we're going to go through and just see how the closed loop is going to respond and just going through some of the basic setup and details that we've discussed in the last training module. Now let's move from our field tuning page here and let's jump over into our Lambda closed loop correction page right here. Now this is what we've spent our time in the last tutorial. We're going to go through just a couple things in our setup and configuration here in order to first go through and just set up our period table. The period table is very important. It's going to be essentially allowing the closed loop correction to make accurate adjustments based on the response or the latency of the actual Lambda sensor placement in your exhaust stream. We can actually figure out what the values in the table should be at instead of just guessing them. Now, Motec recommends to put values here at lower exhaust mass flows of something like 2 seconds, and at higher exhaust mass flows, when we get into higher RPM, higher load, at something like 0.5 seconds. So we're talking about the values in the table being in milliseconds. I'm going to go here just to put some values in here to get started from what Motec suggests from, let's say, 0 to 14 grams per second of exhaust mass flow. I'll put a value here of 2,000. And then at our higher exhaust mass flow, we're going to put a value here of 500 milliseconds. So 2,000 milliseconds is equivalent of 2 seconds. 500 milliseconds is equivalent of a half a second. And between these two, I'll just go ahead and do H and then horizontally interpolate. So what we're going to find is we have some values in the table populated that should be a reasonable starting point. Now, if you're turning on the closed loop correction with these values to get things going, you may find the closed loop correction might be a little bit sluggish. It might also be okay. It really depends, again, on that latency or the response of the oxygen sensor, which heavily relies on where you've installed the sensor in your exhaust stream. The further downstream or the further upstream will affect our values that we place into this period table. So we're going to actually learn how to determine what the values are going to be. Now, I'm only going to do this at idle and part throttle. I'm not going to get into any full throttle. The process would be the same, just so we can keep the tutorial relatively concise here. Now, let's go through a couple other details that we need to take a look at. I have turned on the closed loop mode to enable the fault delay here is set at 10 seconds. The coolant temp threshold for the fault delay is going to be here at 200 degrees Celsius. I'll keep it here at 200 for right now. I'm not worried about having that fault detection enabled, and really not worried about it applying right now. Activate 500 RPMs and higher. We want the closed loop to turn on. Inlet manifold pressure. Now we could set this at 0, or we could set this at something just slightly below what engine vacuum the engine will pull at idle conditions. Now in this case, I'm going to just set it at 15 kPa. I have had this particular engine fired up and running on the Motec here ahead of time, just get things sorted out, make sure the vehicle's going to run and there was no odd problems before we started to film. I'm seeing reported from my inlet manifold pressure sensor around 25 to about 22 kPa at idle conditions. So I'm setting my inlet manifold pressure just slightly below that so that I do have the closed loop activated at idle conditions. We can see right now the throttle pedal should be here 0%. We do want it activated pretty much at all conditions and idle. We can block out and filter out the closed loop from turning on in overrun conditions using our maximum minimum tables, turning them into 3-dimensional tables. That'll also effectively bypass this inlet manifold pressure. We could set this at 0. So we're saying if we set this at 0 and the throttle at 0, that we want the closed loop to be active as soon as we get above 500 RPM. And then we can take care of how we actually apply that closed loop correction to the pulse with our min and max tables. We can actually handle that programming logic in here. I'm going to leave this at 15 and 0 for right now. That should be sufficient, at least for my situation I'm in with my engine. Looking here under control, the gain, Motec recommends to start off with a value here of 80. Now, this is going to be effectively how quickly the Motec will adjust to the lambda error that it's measuring. And it's going to be how many cycles it'll take to make that full adjustment. So if it's seeing that there's a 10 or a 15% error, if we had this at a value of 100, Motec will jump the full correction in one cycle of adjustment. That may be too quick. That's why they're recommending to put a value of 80%. Now, the gain table here does play a role in how the period table is set up. So these both are going to be hinging upon one another. So we want to make sure the period table is set up properly first, then we can evaluate the gain. So we're going to start off with what Motec recommends here at a value of 80 and the default period values in order to make sure that we can start calibrating the period first. So keeping the value of 80, again, that's what they recommend. We can see that right here, start with the value of 80. maximum and minimum values. I'm going to set these to 0 right now. I actually don't want the closed loop to be enabled and to do anything just yet. We want to actually measure the latency or the response from our Lambda sensor in our closed loop routine here without the closed loop actually being active. So what we're going to do in order to sort out this period table is actually go in, fire up the engine, let it stabilize. We're going to go ahead and idle and command it something like 1.0 Lambda. Then we're simply going to change in the area that we're idling at the value from 1.0 Lambda to something like 0.9 Lambda. We're going to see how quickly the Lambda sensor starts to register and read when we command that Lambda movement. And that's what we're interested in for populating the period table. We don't want to guess.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.